Ladies and gentlemen, uh, welcome to the webinar for a just and sustainable space exploration, presented by the Cultural Considerations Working Group of the Moon Village Association. I am Remo Rapetti, co-chair of the working group. Equity and sustainability are among the most important principles stated by the MVA since its establishment in 2017, and goals to be strongly and continuously pursued. Unfortunately, states and companies tend to forget that space exploration should be meant for the interest of the whole of humanity and try to focus on their own advantage. Luckily, some individuals and organizations spend their time fighting against excessive greed connected to industrial and commercial activities in space. Two of those more convinced and convincing individuals are here today to express their theories about how space exploration and exploitation should be carried out to benefit the entire population of our planet and not to be too obnoxious to the celestial sphere at our reach. The first is Dr. Aaron Bowley, who is an associate professor in the Department of Physics and Astronomy at the University of British Columbia. His research explores a wide range of topics, including planetary dynamics, astrophysical disks, meteoritics, space sustainability and security, and space policy. Moreover, he is the co-director of the Outer Space Institute and the co-author of Who Owns Outer Space? International Law, Astrophysics, and the Sustainable Development of Space. The second is a well-known, powerful, and pugnacious lady, Dr. Claire Nelson. The first Jamaican woman to earn a doctorate in an engineering discipline, and the only Black in her graduating class, Dr. Nelson holds industrial engineering degrees from the State University of New York at Buffalo, Purdue University, and a doctorate in engineering management from George Washington University. A winner of several awards and honors, she is the founder of the Caribbean American Heritage Month and the ideation leader of the Futures Forum. She is the author of the book Smart Futures for a Flourishing World. I just wish to remind that after the two presentations, registered attendees may ask questions via the chat button. Lisa Pettibone, the co-chair of this working group, will add comments and ask questions. And now let's go to the presentations. Dr. Bowley will talk about the Earth-Moon system and the need for coordination, cooperation, and collaboration. Please, Aaron, the floor is yours.
Well, thank you very much for having me. And another thank you to the Moon Village Association and everything that you've been doing on this topic. And then further, thanks to Dr. Claire Nelson for joining me on this panel. It's a real pleasure. So I want to talk about the Earth-Moon as a system. And with the concept that this is speaking within the cultural working group, I wanted to try to bring in my positionality and how I think about kind of our shared use of the moon and our shared history of the moon. I want to acknowledge also my close collaborator, Michael Byers, who co-authored with me this book, Who Owns Outer Space, which was a adventure for me in so many ways, a very positive adventure, which really accelerated my path from astrophysics to incorporating also things such as international law in the thinking, and that shaped a lot of where I am right now. Because of my background in astrophysics, I wanted to approach this in a way of how I think about the moon when I look into the sky and I see it, and how I think about the problems that we're facing with the use and exploration, and why it's so incredibly important that we get it right as best as we can from the start, rather than waiting for problems to arise and then fix those problems along the way. So there are many relationships between the Earth and the Moon that create this, that motivate this thinking for a shared environment. I'd like to start with this image here from the Mars Odyssey. And this is an actual image of the Earth and Moon, and just kind of gives that picture, that situational awareness in space. The moon is about a quarter of the size of Earth. It's about 30 Earth diameters away, or about 60 Earth radii away. Now, the moon itself is, of course, of Earth. I recognize many of the things that I'm going to be saying here you'll be aware of, but I just want to talk about it so I can really try to highlight kind of how this knowledge base shapes my thinking. So the best explanation for the formation of the moon is a giant impact by a body called Theia, Theia being the mother of Selene. The details are certainly an ongoing area of research, just how fast the early Earth had to be rotating, what kind of angles would work for the collision, how much material was subsumed into the center of the Earth, so forth. But the basic premise that there was a large collision between Earth and a Mars-sized body that eventually gave rise to the moon is by far the best explanation we have. And this has implications then for the early evolution of the moon. And it also helps understand why there's so much commonality between the rocks on the moon and Earth, such as the isotopic signatures. So if we look at the different types of oxygen and how that's distributed in the minerals, that's very similar to what we see on Earth, as just one example. Very early on, after the collision that generated the material which eventually formed the moon was once really close to Earth, only about 15 Earth radii away. That very quickly evolved, and through the interactions of tides, the Earth and the moon system separated, and the moon eventually became tidally locked to Earth. You could see that a calculation by Farah et al. 2022 here, which shows this is the moon. This is where the moon formed after the impact event, and then there's a very quick movement of the moon away from the Earth, and then after it became tidally locked, it slowed down and moved to its present position today. Now, this is going to have some implications that I want to get back to in just a moment. One of the consequences of that evolution, and the tidal locking in particular, is that now we have a near side of the moon and a far side of the moon, which many of you are aware of. It's fun to think, though, that actually we see about 60% of the moon from Earth due to the rocking that the moon has in its orbit. But there is roughly 50%, but 40% in absolute terms, that we just do not see from Earth. And this creates its own set of challenges. We're going to get into those in just a moment. Another thing that I want you to see from this particular image is how different the near side and the far side of the moon are, as many of you are aware. We have the Maria here, the seas of the moon. These are basalt plains that are floods of impact basins on the moon. And then on the far side, we have this older terrain in great abundance. That's part of what we call lunar highlands. And there are lunar highlands on the near side too. But we do not have nearly as many Maria on the far side. This tidal locking and synchronous rotation, just where what I mean by this is that the moon is rotating once for every time it orbits the Earth. And so that's why we only see the one side. This creates communication challenges. The near and far side are very different. And so there's great motivation to go to both and to operate in both places. But that then immediately creates some degree of suspicion between states that we're seeing play out right now. Just in many ways, unfounded suspicion about what somebody might be doing in a location that another state simply cannot see without infrastructure already on the moon or in orbit about the moon. Another part that is a shared history between us and the moon is one of catastrophe impacts. Same type of thing that ultimately formed the moon. Ever since the formation of the Earth-Moon system, the Earth and the moon have been bombarded by asteroids and comets. And this is a cartoon, kind of or sketch that is showing what that impact history looked like. The main thing to take away from this is that very early on, there was a very, very high cratering rate, and it has since died down to roughly a constant rate since about 3 billion years ago. One interesting thing just to think about, correlation is not causation here, but if we look at the approximate emergence of life, it's right overlaps with when that impact cratering rate slowed down considerably. And so again, there's that relationship that seems to be present. The moon, though, because of this impact, really retains this fundamental record of the early evolution of the Earth and the moon that the Earth has only an incomplete record of. And that's because of a lot of the weathering processes that we have, resurfacing processes that have erased a lot of the cratering record. We do have a cratering record, of course, but the moon has preserved it to a much higher degree. And so by studying the moon itself, that's telling us quite a bit about what happened with Earth in terms of catastrophe. And here is an amazing example of this. This is one of the largest visible impact basins in the solar system, formed about 4.2, 4.3 billion years ago from a large collision. That formed this thing called the Aitken Basin. And this is an area of considerable interest. The Chang'e 4 and 6 probes actually landed in this region. And then with Chang'e 6 is the first time that we've had then a return sample from the moon, from the far side of the moon. We're going to get more into this in just a little bit. This image is showing you elevation and deviation from a reference. So the Aitken Basin actually has quite a bit of a lower elevation. If we go back here, you also see that the Aitken Basin has quite a different reflectivity. There's a connection then that also stems from the interaction with the moon and the sun, as well as with the Earth. And so the outer layers of the sun eventually form a wind, the solar wind. And that wind then has been constantly bombarding the moon. So the Earth has a strong magnetic field, at least relative for the terrestrial planets, and it's able to divert considerable amount of that wind around Earth. The moon is exposed to the solar wind for a very large fraction of its orbit. And because of that, it has then over eons, been had the solar wind implanted in its regolith, its soil. So this is a cartoon that is showing the soil, the surface of the moon. And that surface has been evolving with time due to a whole bunch of different effects. One of them is micrometeoroid bombardment that creates shocks. It breaks up particles, makes it very fine. The lunar dust is very fine. And it also creates glass, very sharp glass. And so we have very fine and sharp glass that makes up a large portion of lunar dust. And that's a major operational hazard. But in addition to what's happening there, we have alteration of the chemistry of the material due to a combination of things such as these cosmic rays, just very energetic particles that slam into the surface, as well as particles from the solar wind. And it's through the chemistry that occurs when you start implanting some of this material that you could possibly get things such as hydrated minerals. You could get water spread throughout the entire moon as a result of the solar wind. You can also implant things such as helium-3, which is then of great interest, at least by some, for fusion, although it's spread throughout the moon. More on that in a little bit. So altogether, one big kind of science project that a number of groups are advocating for is to be able to have geological core sampling throughout the moon, and to do that before it gets spoiled by actions of other actors. Because the moon has this record of impact histories. There actually could have been a common magnetic field between the Earth and the moon, and that could be reflected in the core samples. This was early on when the moon was much closer to the Earth. The moon could have once had a much more extensive atmosphere than what it has today. It has basically no atmosphere today, but it once had a thin but very present atmosphere. And we can test that through the core sampling. And then by looking at the materials over with depth, we take a look at the solar wind over time. And there's much more that can be done. Now, I mentioned water as a result of the solar wind implantation through basically reactions in the mineralogy of the moon and hydrogen. But the moon has also been bombarded by comets, by water-rich asteroids, as well as having these different mechanisms that alter the chemistry and produce water on the moon. And over eons, there's been a collection, there seems to be a collection of water in these regions of the moon that are permanently shadowed. Now that occurs in the north and south lunar poles, with the south lunar pole just happening to have more than the north lunar pole. So you hear a lot about going to the south lunar pole for the water and resources, and that's just a happenstance. It could have been the North Pole, but it happens to be the south. This is just an image that shows then the various craters, and all these blue dots are areas where there's believed to be water, and that's just based on neutron spectrometry. We don't need to get into that, but it's just detections that give you an indication that it's water. It's not a direct detection of water. If we take a close-up look at this region, the south lunar pole, then we see these areas that are very hot and very cold. So this is actually showing you a thermal image. And so there are regions here on the moon that just are in perpetual darkness due to the alignment of the moon and the sun. And because of that, when water, ice, or water in whatever form is able to make its way into these regions and mix within the regolith, it can stay there, where other regions it has to be at a larger depth in order to stay or be in mineral form. So this then creates an interesting problem for coordination and cooperation, which I'll get into in just 2 more slides. But I want to first gain appreciation why we have this situation with the North and South poles. And so there are a whole bunch of angles, whole bunch of things on this particular plot, but there are just a couple things I want you to take away from that. Okay, the ecliptic, this plane right here, this is the orbit of the Earth. That's called the ecliptic plane. And so you can imagine the sun's rays on this diagram as parallel to the ecliptic plane. So the light is always going to be parallel to this ecliptic plane. The lunar orbital plane is tilted relative to that, and Earth is very tilted relative to the ecliptic plane, the 23.5 degrees, which gives us our seasons. But the lunar axis, if you compare it with the ecliptic, it only has a very, very small tilt, only about 1.5 degrees. And it's because of that very, very small tilt that we have these regions that are in perpetual darkness in the craters of the poles. But the upside is that the rims of those craters can also have perpetual sunlight. And this creates then regions of very, very high interest for long-term human habitation. So water is possibly spread all over the moon, but the stuff that's in the regolith that's spread throughout, that's probably in pretty low concentrations. So it's usable, but you'd have to really do a lot of mining in order to get sufficient water ice. At least that's the thought. The high concentrations, though, are in these polar regions. Because of polar regions, this orientation with the moon and the sun, you not only have the high concentrations of water, but you have those rims of perpetual sunlight, and so you could have possibly strong solar power needs. One of the consequences of the moon being tidally locked with Earth is that its night is about 14 days. And because of that, power is a real issue. You have to have your batteries survive a very cold lunar night. And so we have to then think about how we're going to store energy during the lunar night if we're going to have long-term operations, or we find locations where we can always have sunlight, or if we don't have sunlight, it's only for a short period of time. And so this really narrows down the number of places that we would want to operate in the long term if we want to rely on solar power. We could go to nuclear, but that brings a whole bunch of other issues. So the ideal locations on the moon are going to be highly desirable and could be quite competitive, which means we have to have that coordination, cooperation agreement among all states set, because we don't want to be fighting over resources on the moon like we do on Earth. There are, of course, many other resources on the moon. Many of them are in very low concentration, spread throughout, so it would take quite a bit of mining to actually extract them, but there are a large number of resources there. The moon and its mass distribution. The moon is a very interesting body because the far side of the moon has a very thick crust, which is why it doesn't have very many Maria. And the near side has a thin crust, which is why it was able to have all that volcanic activity, just because the magma was able to extrude. Now, it's not yet really understood why there's this so-called dichotomy, but it's there. What it means in the dynamic sense, though, is that the center of mass of the moon and the center of figure of the moon, kind of where we would draw a geometric center, are offset considerably. And what that means is that long-term stable orbits about the moon are rare. So this brings a whole nother view of sustainability. If you want to put something in orbit for a long time around the moon, there are actually only a few orbits that, I'm simplifying it quite a bit, but there's the orbits that you could put something in that are very long term are much fewer than what you would have around Earth, and it creates a very big operational constraint. It also means that if you're not operating in one of these very stable orbits and you have debris that you jettison or create, that debris is going to eventually strike the moon. And so it creates this new operational hazard. And again, those very few stable orbits could actually be competitive without cooperation and coordination. This is a fun diagram that is showing a dynamical landscape. So what this is doing is this is scaled units in X and Y. You're looking down on two masses that are orbiting each other. However, we are rotating with those masses that are orbiting. So M1 and M2 are two masses, and they're going around each other, but we're also going around with them. So M2 always appears to be over here, and M1 always appears to be over here, just because we're rotating with it. Now, what we can do is we could write down energy contours within this rotating frame. And with that, we can constrain where bodies are able to go. We can't tell when they'll go there, how often they'll go there, but we can kind of say this is an allowed region. So from this kind of map, we can say we could put something in orbit around here, and if it has the energy within these contours, it will just stay here. But if we give it a little more energy, so instead of saying it has energy that's white, it goes to energy that's orange, now you can have objects that go back and forth between M1 and M2. And they could stay around M2 for a while and then suddenly switch to M1 and then suddenly switch back to M2. And this becomes really important for understanding the dynamics around the moon and how it becomes connected with the Earth. Some of those points that we're showing here, L1 and L2, these are Lagrange points, and these are areas that are quasi-stable. They're actually unstable equilibrium points in the sense that if you could balance a pencil on its tip, it would stay balanced. But if you just nudged it ever so slightly, it would fall over. So it's an unstable equilibrium. But if you add just a little bit of station keeping to it, just a little bit thrust, you could stay in these regions for a long time. And so this was recognized very early as a needed location for facilitating lunar far side operations. And Chang'e 4 actually utilized this. They had a relay satellite that they put in L2, and that relay satellite communicated with Chang'e 4, and the relay satellite was then able to communicate with Earth. And so they were able to have these communications because of that dynamical landscape. But again, these operations produced a lot of suspicion, particularly within the United States, of what China might be doing on the far side of the moon, why you would have a relay satellite here and so forth, although it is actually really quite simple why that relay satellite needs to be there. Ultimately, we have this cislunar highway. There are these points around the moon within that energy space that are very desirable for communications and space domain awareness. You see a lot of rhetoric about there being high ground in kind of and taking the high ground for cislunar space, but that's a really, really bad analogy, and we could get into that in questions if we want. I'm going to skip over it for now. Debris in orbits about the moon will probably be unstable and slam into the moon, and so that has to be part of any type of operational consideration. And debris can go back and forth between the Earth and the moon. So say you try to solve the debris problem by just kind of pushing it out further in its orbit. Well, now it can just create debris streams between the Earth and the moon. They'll go on for a while until it either hits the moon or hits the Earth, or maybe escape entirely. One final thing that I have to bring up, just because of my background in astronomy, is that the lunar far side is a radio quiet region. What you're seeing here are calculations of radio emission kind of coming from Earth. And the dark region here is showing where the radio emission is from Earth is so strongly attenuated, it's basically no longer present. So there are radio quiet zones on the moon. So this is showing the far side. If you put telescopes here, for example, then you could do science and do a type of space exploration that we simply cannot do from Earth. One, due to natural processes on Earth that create interference with radio, and also interference from satellites, TV stations, cell phone towers, and so forth. I want to end with some legal and policy considerations, because all of this ends up kind of shaping, all of the physical considerations end up shaping kind of how I look at the policy considerations. Now, one of the things I do want to emphasize is that there's an incredible amount of law and policy that already applies to space. You hear a lot of comments, a lot of rhetoric that, oh, there's no law in space, it's the Wild West, it's all this other stuff. No, that's not true at all. The problem is ultimately that the law that we have for outer space is vague and binding. So there are a bunch of principles that already exist, but it's up to states to ensure that they follow them, and how the interpretation of how you follow them changes with time. There's an exercise we went through recently at the Outer Space Institute where we just looked at existing law. So this isn't like idealized. This is not what we want to see. This is what already exists. We said, can we pull out core principles from the law that already exists that everyone can build on to actually have a cooperation, coordination regime for the moon? And there's actually quite a bit. And so you can find this document on the Outer Space Institute website, but we have peaceful purposes. You have the prohibition on appropriation, adherence to international law. Remember, international law and the UN Charter apply to space. Is the common interest, benefit of humankind, freedom of exploration, but you can't interfere with each other. There are more here. There's the due regard, consultation. Science comes up in the treaties all the time. It is a big unifier. And no military installations, no nuclear weapons. Space law is also an arms control law set of treaties. I mean, it's really important to view it in that sense. Anything else? Because international law extends to space, principles of environmental principles, such as a precautionary principle, that should say the preventative principle, there's a tenable argument that those also extend to the moon and should govern a lot of our operations there. Two final things to end. What about resource extraction? Because this is, of course, is a big topic. Resources can indeed be extracted from areas beyond national jurisdiction, and the moon is an area beyond national jurisdiction. So the idea is that you could own fish even if you don't own the high seas. That does make a tenable argument that states, operators, actors can take resources from the moon, use those resources, consume them without actually violating the Outer Space Treaty. However, this needs to be decided in a fully international forum rather than ad hoc political commitments. And it's those ad hoc political commitments, which is where we're going now. On the issue of safety zones, and I do know that safety zones is something that the MVA do support. I actually have a problem with safety zones. It's not the principle of what they're trying to accomplish. It's rather how they're trying to accomplish it. So these safety zones are the idea that we set some type of boundary around to let people know that certain operations are taking place, and you do that for safety. And it draws from ideas such as the platforms in the high seas for oil. But why draw boundaries around something that shouldn't have boundaries? What makes the zones meaningful in the first place? The operations you're going to have non-unique kind of limits on that. And what you might think of as the right distance for a particular zone may vary from operation to operation. And so actually a zone has multiple zones to begin with, depending on what's happening. But with what the actor is doing, as well as the second actor. Why do we have to have the boundaries in the coordination mechanism to begin with? Why not simply have things like lunar safety alerts, letting people know what activities are taking place and where? Anyway, that is something for further discussion. To end, coordination, cooperation are essential for long-term responsibility of the moon. We want to prevent the loss of fundamental science, reduce security dilemmas, prevent spoiling of the natural human environment, natural lunar environment, and certainly recognize that there's a tremendous shared history with the moon. And finally, there's considerable law that we can use already, and it's just a matter of guiding states to actually act on that existing law, which is different from having to start from scratch. There are fully international projects in space that we've done. We have the International Space Station, we have COSPAS and SARSAT. These are mechanisms that have lived through major geopolitical tension. You still have U.S. and U.S. astronauts and cosmonauts going up and down the ISS together. You still have search and rescue being called for from satellites from adversaries. We want to retain a balance of freedom of access, but recognize that we have to show due regard and non-interference. And of course, accessing the moon has direct implications for the Earth environment, something that I haven't talked about, but something that I just want to make sure is said, that rocket emissions, re-entries, effects on dark and quiet skies are also effects for the Earth-Moon system that we have to fully consider. And with that, I will end. Thank you so much.
Thank you. Thank you, Aaron. Thank you for your very interesting and detailed presentation. And now it's Dr. Nelson's turn. She will speak about how we share the moon, analog research as a modality to help ensure space for all. Claire, please, you can now start your presentation.
Are you able to hear me?
Yes.
All right. So I want to jump in the way I normally jump in by reminding people that I first went up to the moon in 2034 to help set up the Human Heritage Site on the moon. And how I got there is a long story. But needless to say, I started there that story by asking the question of how we share the moon. And it's interesting we're having this conversation today on the beginning of the conversation of the UN Summit of the Future. And I'm actually sitting outside a room where some of the people who are working on space as an 18th SDG are having a conversation about what should happen. And this question of the moon as shared space and the future as shared space is something I think really, really, really needs to be explored. And so my story, Moon Runnings, the life and times of the first Jamaican on the moon, creates a whole world that is set between Earth and the moon, a whole movement called United Planetary Society to Share the Rights to Space. Here they are. This is their logo of the organization, which in my story world, this organization exists across the world, across boundaries, to set up new structures, new institutions that will allow us to really not just carry over what we know as the current institutional and legal frameworks from the current dominant ways of working, but cultivate new ways of working. And in my story, to make it palatable in creating the story world, I had to start with something that would be, let's say, beyond the pale. So I began with the concept of what do humans have in common? We have in common the fact that we all play games. We have share a faith. We have also this desire to preserve history and to talk about our culture. And we've all from a time of we know man to be a woman, man, human to be born, have always had the idea of looking up at the moon and writing stories and telling folklore. And so in Kijiji, Kilimia, which is the village that I claim to be the place where the human heritage site on the moon would be, is about really preserving human relationships with the moon and having people of all walks of life that want to work out exactly what that would look like in the future. How do we ensure that we don't take the bad habits of our civilization to date forward into the future? And so we're kind of stuck in this paradigm of, okay, this is what the international law says right now. This is what property rights are. And one of the issues we have to talk about as a group is, what are property rights in the future? What does it mean to say we are going to own a part of the moon? Can people even own anything on the moon if it's a common? The moon is a global commons. We all look up at the same moon. And so if indeed we're going to talk about ownership in the Western traditional concept of property rights, where you can sue somebody for doing something on your piece of land, your piece of the moon, and then we will have to have a much broader conversation than we're having right now than just governments, because we know what happened when the conquest of Latin America and Africa happened. Everything kind of shifted, and that's not the way we want to go forward into the future. And so I use art and the art of storytelling as a way of having these conversations. And while my one-woman show is meant to be fun and like romp, I try to make it as humorous as possible. I talk about, for example, the real life situation where I reached out to the Lunar Embassy, which is a US company that was set up many years ago. A gentleman discovered that the UN Outer Space Treaty did not say no person can own the moon. It said no state can own a moon. So he laid claim to the moon and decided that he was the owner of the moon and started to sell our titles to the moon. And so when I was writing my show in 2016, long before I got involved in space, I called the office to ask, to see how it really worked. And I called him and asked him, I want to buy, a piece of the moon. They told me how much it costs, $50, and we'll take out the piece I would then carve what I'd want. Then I saw that they were having ambassadorships. So I said, oh, I see you have ambassadorships. How could I become an ambassador? So he said, man, you gotta pay us $10,000 and you gotta guarantee a certain number of sales for the territory. So I said to myself, oh my God. I had to meet the phone. I said, what? So he repeated it. And I said, oh my God, they're really serious. It's not just a gag gift. I mean, I thought it was just a gag gift, like a gag company, a gag gift. They're really trying to make money off of this thing. And it sort of sent me tail spinning. And I use that in my performance as an inciting point for having people realize that these are real life problems we have to work out. If indeed we're not, no country can own the moon, can one person say they can own the moon, like this gentleman is doing and selling it? Suppose somebody had the money and the wherewithal to actually get a rocket and get to the moon first. Can they say it's not, in the case of whether it's Shang-Chi mission or the Indian mission or the SpaceX mission, can they then say SpaceX owns this piece of the moon, given that, the Outer Space Treaty doesn't talk about individual companies owning the moon. So we have a lot of work to do. And I think using storytelling, using the art form of role play, etc., we can do a lot of work to support these conversations. And this is why I think the analog process that I'm engaged in is so important. Right now, I'm focused more so on the science of it and not so much the art of it. And you see here, I have given the name I want to give it because I want to make it as real as possible. And so the analog research village we're talking about building in Africa will be named Kijiji. And so the project has started where we have set up already 2 conferences. We had the founders of what we're doing. We talk about space for all humanity, space for Earth, space sustainability. These are the things I've been talking about. And talking about how do we design an analog in East Africa, in West Africa, that will allow us to bring the African continent into the room and possibly the Caribbean and possibly the Pacific, because these are mostly, for the large part, non-spacefaring nations that need to be part of the conversation. And so I'm excited, for example, to see that as from a small island perspective, that Mauritius and the Maldives have kind of launched their own conversation. Mauritius just launched a satellite earlier this year. Maldives had its second conference this year talking about the use of space for Earth. But I see that we have work to do that can be really practical on the one hand, giving the scientists in those countries a way to see themselves as a part of this cultivation, but have been not so lucky so far in getting, I would say, the policy people or the arts community involved in talking about what it is. Because even in Africa, when I've asked, okay, who can perform a story about the moon? They're like, oh, we don't have any, but they probably have, but they have never really thought about it in the context of which we need to use culture to inform the way we have these policy conversations. I think this idea of separating culture from policy is a false one. I think we can do both. And I think the best way we're going to deal with these question is not to do the traditional way of just a couple of guys locked up in a room negotiating country by country. I think this requires us to have embedded in a broad spectrum of the human endeavor through Moon Village Association, for example, through centers like the one that Dr. Aaron runs in Canada, have this story, not just a story that is told by me. And the reason why I say not the story that's told by me, the way I've written it and performed it, when I do workshop with it, I bring people into my story. I find out what is their relationship to the moon? What do they want to do on the moon? And how can I get them engaged in seeing them as part of the story I'm crafting, which is saying space for all, space for all. So the project we're doing, Oasis, is about creating, first of all, a first analog, physical analog, so that we can be part of the conversation. There's a community of analogs from Hawaii, Lunaris, others in Lunaris in Poland, Hawaii. There's obviously the ones owned by the government. I'm talking about the ones that are owned by civil society. Mars Society has one in the desert in Utah. I'm sure there are others that I'm not aware of. I think they have a list of 12. And I've been going to their conference for the last 3 years and trying to insert the voice of the non-spacefaring countries in their process. And they're going to have something called the world's biggest analog next year. And this process started last year. And so with that in mind, I said, I have to launch this African thing right away. And so we've set out to do this. And we began with this concept, okay, we can't just have one place in Africa because first of all, it's very big. People don't regularly go back and forth because it's very expensive. At least I should have one facility in every regional grouping. So it's East Africa, it's the SADC region, it's the ECOWAS region, then it's the Lusophone Africa, it's the Francophone Africa. There's so many ways in which Africa itself is divided. That may end up in a network of 7. But at least let's start with what we have. So as of now, we see Oasis as having 2 facilities, one in northern Ghana, one in northern Kenya. One will be in the desert, one will probably be a cave base because we're looking at maybe settlements that could mimic different aspects of life on the moon. And in these cases, the engineering schools in the universities of which we have been speaking would participate in designing off-grid technologies, looking at the water, looking at the energy, looking at waste management. And to make it palatable, we're looking at talking about it from a framework of solve for space, solve for Earth, because as you well know, right now, when I was in the desert in Kenya last year, for example, I saw so much plastic, I was freaking out. I'm like, oh my God, they don't know how to treat the plastic that they have, and they're so isolated. There's no garbage service. So what am I going to do with all this plastic? This is a problem. It's a problem because I was in a meeting and I heard a very senior NASA official say, when I asked him, why do you have a competition to have people figure out how to jettison waste on the waste to Mars? And he said, oh, there's so much space out there. One piece of thing we jettison away won't make a difference. And then I said, that's what we said 1,000 years ago. And now the sea is swarming with plastic, even plastic in our bodies. So we can't be so careless as assume that our design system should even follow what we've done in the past. Anything we design for space should be done with a circularity in mind, right? We should not be thinking about talking about going to Mars and jettison waste, designing containers that we can jettison on the way to Mars. Why are the containers not being designed in such a way that can be reused when you get to Mars? You're going to need stuff on Mars before you actually can build anything on Mars. So I don't understand this logic that you even we're so callous to talk about there's only one piece of plastic in space. There's a lot of space out there. This attitude has got to stop. It really has got to stop. It's annoying, it's distressing, it's disturbing, because so is the idea. I heard somebody say, oh, we need to hurry up and get ready because we have to escape Earth and have live the good life in space. What good life in space? We don't know how to breathe oxygen. We don't have water. This is a very dangerous exercise fraud. So people, I think, are watching these movies and thinking we're there yet. We're not there yet. We're like maybe 100 years away from any really proper civilization living, maybe not 100, maybe it's even 50, maybe it's even 20. But the fact is, whoever goes up in the next 10, 20, 30 years are going to have to live very precarious life, knowing that they're taking literally their lives into their own hands because we have a lot to figure out. And so the analog research simulation, I think, should not just be about the research of space science of it. I think our analogs have to go beyond that to talk about the culture. I think we have to have an analog simulation process that we also have those lawyers who are thinking through these ideas now in terms of how we own space, who owns space, how we share space. To have conversations about, what if we actually had a situation where a private company, quote unquote, owned a piece of the moon? How would this be treated? We need to have simulation labs. And so one of the things I was honored for in the Ascend Diverse process last year was my call for a space collaboratory, a collaboratory that allows us to do some game theory, some digital twins, using these analogs again to do digital twins, virtually digital twins, physical digital twins. But we have to use the analog research process to actually model what would that look like to actually have a court case where somebody is suing for something because these laws aren't ready yet, as opposed to just the traditional treaty approach. We write a treaty and then you figure out, no, we have to work from the bottom up. And this is why the work we're doing at Moon Digital Association has to be democratized very quickly. We have to have it be as broad as possible. We've got to get these people who are around the world who are seeing it as just a fun thing to do. The young people, the old people like myself, well, not so old, let me call myself wise people like myself, to see it as not just a fun thing to do, the thing they're only doing it because of they love Star Trek or Star Wars or Avatar or whatever, but really to see it as something they're contributing to designing our future in a very different way. And if you would see, the current Summit of the Future document only has one paragraph on space. And luckily, I was able to insert myself in the process to ensure that coming out of the UN Summit on the Future, there's an impact coalition on space, the Space Matters Impact Coalition. I was able to drag Giuseppe into it and drag MVA, because I had to have at least 5 groups to have it happen. I had to drag them in. I said, please sign up. We don't know what we're going to do exactly yet, but just at least sign up so we can exist. So we exist on paper as one of the impact coalitions that came out of the NGO meeting, because we have to ensure that as governments begin to realize that we, the human species, are hurtling on a collision course with self-extinction, and that space is one of the fault lines which we could do real serious damage if we don't get this right. We can go to the moon, and as people say, oh, we can just put nuclear stuff up there. Nothing we can ever do on the moon can ever impact on Earth. Says who? How do you know that? This is like totally for me, things that make me go like, what? So even today I'm speaking, I said, I want us to look at some different values. And I talk about the need to approach space with humility, equanimity, reverence, right? Let us really, and I think culture is the way we can do that. And so I see my story, Moon Runnings, I talk about in the story, I talk about the Space Goodwill Games, right? And I create a whole game. It's called a steeplechase race. That was steeplechase race where we have invented these things and we're going to race on the moon. And the second part of the village, we have the Vault of Human Heritage, and we have collected all the stories and all the poetry and all this love songs about the moon. And they're in this vault. So when the space tourists come up, they get to explore that. They're going to this metaverse and site. And I can imagine 10, 20 years from now, you'll have the capabilities like what we have as Star Trek, VR, that you can pretend you're living in the story. And these are things that are going to help us at least begin to humanize it and see ourselves as how are we going to actually live with space. In one of my workshops, I allowed the students who were in the room to decide, did they even want to be in space? Some of the students said no, they didn't think we should be up on the moon. And I said, great, you are in the story too. And I had them do their part. Why did they want us to be on the moon? And I want us to be very real about understanding that the 8 billion people in this world have different ideas. And I said it in one meeting I was at, and I said, before you go off thinking that everybody is hunky dory with this idea of being on the moon, I can tell you, don't be surprised if a very radical movement starts about not going to the moon and having human presence on the moon, because for some people, this is very scary, very dangerous, and very detrimental to their vision of their cosmic vision of what humanity should look like. So we have work to do, and I think we have to use the arts and culture. And I certainly, luckily for me, on one side of my brain, I'm an engineer. On the other side of my brain, I'm a storyteller. I have also on my fictional village, the chapel of all religions, right? And one of my comments I make in the performance, I talk about, so which way is Mecca if you're on the moon, right? Because some of these things really say, I mean, if you talk about space law, I know the Islamic countries have worked out, if you're a devout Muslim, how are you going to do your prayers, right? Because it's not going to be the same, right? So we have to recognize that the way we live our lives, the cultures, the stories, the mythologies we bring with us. And so we have to actually create a new myth around how we share them on. And those are the kind of things I'm working on. Telling stories, I'm finding stories about different cultures, the Aboriginal people from Australia, the stories about their creation, stories about the moon, African stories. And I'm working towards creating maybe a new 21st century version of a creation story that allows us to build in, quote unquote, the science we know today, along with the mystery of what we don't know as yet. And I think this is important that we do this with intention, that we as Moon Village Association make an effort to really make some of these ideas, even my crazy ideas, popular ideas, such that we can have, there's a ground feel, if you will, of this thing. So right now we're focused heavily on the research and setting up the site. At the stage now where I'm beginning to talk about doing a business plan to get fundraising, because we want to participate in the world's biggest analog, which will be next year, October. We have gotten approval to do the research we want to do, which will be off-grid solar. So setting up the site to do off-grid solar, and then having each of the 12 sites that will be doing the simulation for the whole month of October next year, test some of our solar cells that we have with a climate equipment. They're just a small set. We can't afford it. If we had money, we could do a big equipment, but just a small, let's say, pilot version of the equipment we think might be used in Kijiji, Kilauea on the moon. For me, it's real. This village on the moon is real. This village on the moon that's not controlled by one country is real. I see Kijiji, Kilauea as a civil society controlled and dominated space. It's not owned by one country. It's owned by an organization like MVO, where many people cooperatively raise funds, cooperatively donate money to build it so that we can really do what we need to do differently and make it such that people see themselves in it. So as I think about, I'm going to wrap up, I know my time is up. I see that we're going to need some help in terms of more volunteers on board. This is the African idea. I'm trying to make it such that we are in the world's biggest analog next year. But I do see that we can use all these kinds of people from all around the world: waste management, materials, doctors, nurses, storytellers, filmmakers, fundraisers, marketing. Everybody has a role to play in making this happen. So we're here for this. MVA is here for this. I'm grateful to have been selected to be an international ambassador for Goodwill Ambassador for International Moon Day. We have a lot of work to do. And I think those of us who love the culture and the arts will have to help tell the story that Dr. Aaron is talking about, that the moon and the earth are one system. They're not two systems. And so that we move with care and move with reverence and be smarter about how we share the moon. I'll stop here.
Thank you, Claire. Surely your speech was inspiring and motivating. Thank you. Elisa, please, do you want to comment or to ask questions?
Yeah. So hi, Claire. We weren't introduced. I'm the co-chair with Remo for the Cultural Considerations Committee. I saw your talk at MVA Italia as well, which I thought was really just as stimulating. One thing I thought maybe would be nice to hear about is or to find out more about is the kind of value that non-spacefaring nations can add to the conversation. They have expertises and have, environments. For instance, in Africa, they're used to living in extreme situations, et cetera, where, the environment is quite challenging physically. And this actually probably comes through. I don't know about the myths and legends there, but all these things are actually tied into their way of life. Can you talk a little bit more about the kinds of contributions you see these other nations bringing to the table?
I definitely think one of the things I was talking about when I was in Kenya last year, I did Ghana this year. I said to them, the nomads that live in the northern part of Kenya live very precarious lives. Their bodies are actually adapted to living on very limited amounts of water, for example. They also have managed to stay alive with no refrigeration for their food. So there's a lot they can do in terms of food science. I've tasked some of one of the guys in Ghana this year. He's a food scientist. We're looking at some of the food that they use, which are preserved for non-refrigeration. See if we could do some research to make it more nutritious, that it could become one of the space foods, for example. So I see there's some potential hardcore research that they can do around food science. I think we need to go back and look at also traditional land law and behavior from both African tribal landholders and also indigenous peoples in the Americas. How do they deal with ownership? Because we might be able to go back to before the colonial era and say, wait a minute, let's not discard the fact that for years before, the idea of a private person owning a piece of land, there were ways in which people lived together and actually own and share the land and share the benefits of the land. So one of the things I've said to people, let's not even call the surface of the moon land or the surface of Mars land, because it's not land. Because once you call it land, we have a problem. It's going to be then treated like land. We need to use culture. Are there words that exist in indigenous languages that we may not be aware of, not English or French or Spanish or German, that are used to describe the surface in a way that we can then create new law because it's a new idea? So we can use words that exist in these countries, these cultures or subcultures or tribes to describe things differently. So we don't take the baggage of the legal systems that we are used to in the last 100, 200, 300 years, 400 years or so of the Judeo-Christian principle that use the biblical verse, okay, go out and have dominion over, to mean that we're really going to just go and control everything, as opposed to go out and to have dominion with you being the steward of X. So we have to help convert the language from dominion over to stewardship. I think if we can do that using culture, we have a better chance. So I think these are the ways in which I've been encouraging the young people who are in the space generation, lawyers, for example, to really think about what are they bringing to the table. Are you just going to parrot what is, or are you going to really bring something new as a lawyer? You need to be doing some moot courts in your countries that are looking at, can traditional law solve the problem of legal ownership in space law? They need to be thinking about those things, not just assuming that everything is going to come from what already exists. We have already outstripped what the treaty has said. So we have to leapfrog and go back and fetch from the past some things we might have left that might be useful for us. And even that concept of going back and fetching, a very African construct. When I was in the Pacific, one last thing, I realized I was asked to speak about the future, and I was asking them, and then I found out locally before I did the speech that the Pacific people, Fiji natives, do not see the future as being in front of them. The seat has been behind them. And I'm like, ooh, how do I talk about this? Let me see what language I can use. And so I said, well, I have to find something that's also comfortable for me, right? So you know that the Sankofa bird in Africa, their head is turned to the back, but the feet are facing forward. And I just opened by saying, okay, let me confess that unlike you, I see the future as facing forward. But I want to share with you that there are some cultures like yours that, people talk about looking back to go forward. And so I think we have to find these touch points where we see the commonalities. And so I really believe if we take the time, some of us to look at some of the stories, some of the mythologies, some of the proverbs from these cultures, some of the food practices, some of the land practices, we're going to find ways in which we can support the scientific as well as the legal and institutional arrangements that have to be done. But I really, really hope that we get the support as a group, MVA that is, and other groups like ours, to do this sort of a quote unquote scientific approach, as in do the laboratories, do the moot courts, do the analogs, whether they are scientific analogs or policy analogs, so we can get so we can learn more from doing. And then we can say, oh, okay, when we did this verbally and we went into the world for a month, we pretended we were lawyers for a month on the moon, then realize, oh my God, we almost killed ourselves. This is not going to work.
Well, I think you're right that language is really important, and the way we term things is really from each of our own perspective. And for the most part, it's the Western language framing space exploration, and it would be nice to see us move and evolve beyond that. One of the words which you brought up, Erin, in your presentation was resources, and how do we coordinate all the resources of these different factions actually on the moon. And sometimes I think the word resources itself, it almost implies a type of ownership of the surface of the moon, or its material values. Can you talk a little bit more about the problems you see coming up around resources? Can you unmute yourself?
Sorry, I had to find the cursor.
Thanks.
Yes, I mean it's a great question, and one of the things that I wanted to try to highlight with that is that resources go beyond just water. It goes beyond placement and how you move about and how you can get to one particular place. It goes to communications and energy and so forth. But to your specific question of, doesn't this imply some degree of ownership? And I mean, I think it does. And we have people who are wanting to go and claim, a various forms of ownership of the moon, whether it's of parts of it or whether it is kind of a de facto occupation. And this is one of the things that I very much worry about if we don't have a fully international then regime that we've developed for having that coordination and cooperation on the moon. Because as soon as we start trying to go for, we're going to own it, we're going to grab this piece or that piece, oh, maybe we're leasing the land for now. You start using all these other, terms that have some degree of ownership associated with it. I worry that things like zones that people have occupied do become de facto occupation. The reason why I was really kind of focusing on, the acknowledging the resource use is because we're seeing that happen already right now. And so it's a matter of trying to do the appropriate trajectory changes to ensure that we're not repeating many of the mistakes that we've already done here on Earth. There will be missteps, but we want to minimize those missteps as much as we can. And there is absolutely a very important discussion of what we should and should not be doing on the moon. And we shouldn't take it as a given that we can build a large radio telescope on the far side of the moon, that we can operate, do all this resource extraction. Even things that I would like to see go forward, not necessarily large-scale resource extraction. I don't want to see that go forward, but like the radio telescope on the moon. I can't take that for granted, because there are people who will say that and say, no, that is changing this natural environment. And so we have to have a way of talking about it with each other that does involve more people. That's not just a handful of powerful states sitting in a room.
Yes, I mean, it seems that there'll need to be really an international conference where we bring a lot of these people and ideas together, and they hear each other's discussions, like the climate conference that happens every few years. It feels as though now things are accelerating, and we need to get everybody in one place if possible. And it'd be interesting to see that happen in the next couple of years. It's not just the Artemis Accord that will sort of solve those problems. It will be us all working together internationally, and we have a place to do that, maybe once a year, every 2 years, something like that. But just another little question for you. I know you mentioned something about core samples. Are we running too late then, Remo?
No, there is a question in the in the
Q&A.
Yes.
Yes. Go ahead with that, please. Yeah.
What kind of life we might find on the moon or elsewhere should we accept as an outer space civilization and the species from a metal point of view?
So for the moon, I mean, life in the solar system, life beyond the solar system is such an amazing thing to be thinking about. In my view, it is outrageous to think that that Earth is the only place where the experiment of life has occurred. The moon, as far as we know, is not able to hold any form of life. If you go far enough down, and is there enough energy and a medium for chemistry and shielding from benefit that you might be able to have life? It doesn't look like that's the case, but we've been surprised in so many different ways. And so, there's an ongoing discussion that's ultimately set by kind of COSPAR, an international forum that tries to understand kind of how careful one needs to be on one location versus another. There's broad agreement that everyone should be super careful with Mars, that you need to be super careful with the icy moons around the giant planets that have giant global oceans and have energy sources through volcanism. The moon is someplace where people tend to be much more relaxed because you have such a harsh environment on the surface. I mean, so hard. We already had a group, smuggle life forms onto a spacecraft, which then crashed and spread these tardigrades on the moon. There's very little, I think, support for the view that those tardigrades will reanimate at some point, but there is kind of this just spreading of material on the moon that is not being as careful as one might have. To your question of what type of life could we find on the moon, I don't know. There's no analog that we have of life that we can find on the moon. But that doesn't mean we should be careless about it, that we should just spread whatever we want all over the moon like tardigrades. And then as you go to different bodies, you do have to have even greater and greater care.
Yes, Lisa, please go ahead.
Oh, sorry, pushing the wrong button. I was just going to ask you, I know that during Apollo 15, they did some core drilling on the moon. And I was wondering, which is one of the things you mentioned, that would be one of these activities that would give us a lot of information about how our planet was formed and the relationship between Earth Moon. Did that reveal anything interesting? I haven't read about that.
Oh, yeah, no, the core samples are definitely revealing about the kind of how the regolith changes with depth. The material from those core samples are still being, analyzed, but they were still fairly shallow when you get down to it. And so we're talking about much deeper cores of greater material and sampling in many different areas. One big thing that has happened over the evolution of the moon is that all of these large impacts have spread material all over the place. So different regions of the moon get mixed with other regions of the moon. And one way to disentangle that, hopefully, is to, ultimately go deeper and get lots of samples from different locations all over the moon.
Wow.
And what we don't want to have, though, is just have various contamination from human activity in the regions that you might want to sample. As you go far deeper down, that's not as much of a problem, but certainly for the regolith, that could be a huge problem.
Thank you.
I think I have a question for Claire.
Mm-hmm.
In reading your book, Smart Futures for a Flourishing World, what struck me the most was your idea that we should, quote, borrow from the wisdom of indigenous people much that we have in our arrogance defined as backward, to find our way forward to a better place. Frankly, this idea, if taken literally, seems to me quite unrealistic. Can you explain why you think it is not so?
I think just as the UN Summit of the Future is recognizing what the indigenous people have always said, we belong to Earth. The Earth does not belong to us. And have always sought to have a more stewardship approach to how we treat the physical realities around us. So we used to laugh and say, oh, they worship the trees. Oh, they worship stones. Right? Maybe it was a misunderstanding. Maybe they saw them as sacred in a way that we are sacred and sacred to their lives, in ways that we now need to go back and look at. And so to go forward, if we're to survive, knowing the ways in which we can self-destruct, and there are many ways which we can self-destruct, which are all man-made, right? Synthetic biology being one of the ones. If we had a real Star Wars, would be a second one. If we happen to use nuclear energy in space and something goes wrong, we are going to be a lot of damage. So this is not, we really need to think. And so the fact that the UN Summit of the Future talks about space, the fact that they're in this group that is having the event that I'm at now, there are 93 organizations that have signed up for space for the SDGs and being sustainable. But as I said, we have to look at it from different values. We can't all be driving forward out the values. What does it really mean when we say a flourishing life? And so when you look at what's happening in the EU, for example, they recognize that as wealthy as they are, people are still unhappy. People are still mentally distraught. And so they're moving towards metrics like well-being and gross national happiness. Wales has a futures generation commission, because we recognize that all the technology we have is necessary. We might have more things, but we're still not any happier as a species. And so as we look at the moon and how we want to explore the vast wonders, I mean, I can tell you the first time I looked up in a scope, which was again 2 years ago, and I saw that there were actual rings on Saturn. I was beside myself with glee. I'm like, oh my God, there are really rings on Saturn. I was like, this is so much mystery and so much beauty. We really have to change the paradigm shift of what values are going to drive our exploration. And so the faster we kind of internalize the idea that we belong to the cosmos. The cosmos do not belong to us. And that's what I think the principle that MVA has to go forward with. We're here for a short time in time. We're on a long line of humans that have gone before us, and where was a blip in time on the screen, and we need to leave something for others to enjoy. So let us go forward, but with that mindset, we belong to the cosmos. The cosmos do not belong to us.
Yeah, sure. There is another question, but maybe it was meant for Aaron, I'm afraid. Let's see. The Artemis Accords country consignees are now 43 and still counting. In your own point of view, for both of your speakers, should we invite more countries to sign the Artemis Accords, or should we make another accords, but a signifying accords that will be easily signed by all 190 plus countries around the world through the United Nations?
I'm going to answer that in the only way I think we should answer it. I think the current dichotomy, which is the Russian way, Russia, China, I think Saudi Arabia has joined both groups, right? But very few countries are going to be able to afford to join both groups, right? So I think we need to have a third accord, which is UN centered, and maybe it's something that we, the people, can be the one driving. And so if we really can have, we're talking about space for the SDGs, and their vision is that, okay, now that the summit has on the table, now there are arguments to see space as a critical, yes, resource, but also as critical driver for human survival, right? Then if we have space for the SDGs being approved, let's say by next year, by 2030, then we would have a lot more people than the few of us who are an MVA party to this idea that starting with the moon, which we definitely is our next door neighbor, it's our brother, it's our sister, we can ensure that we use that as an entry point to say it's not just for the spacefaring countries, all countries. And we, the NGO movement, will have to drive that. So I think we have to start that from now. We have to work out, even within our own groups, we already see that there's dissension among this idea of ownership, for example. People are very much into this. We must have ownership, or the private sector won't want to invent. There has to be a third way. And I think we can find it. We may have to ask people to write science fiction novels to find it, right? Because sometimes it comes in a dream to somebody, but we've got to do the work. And I think these are the things that MVA can do if we see ourselves as the guardians of the galaxies, beginning with the moon, right? And really use all the means necessary. We're not a rich organization, no, but I think we're rich in intellectual capital. And I think we can certainly take up the mantle of MVA because, I mean, if we believe that the moon belongs to all of us, and there are 8 billion of us, then there's no reason why at least, 80 million of us could not put $1 each, quote unquote, and do something differently to change the way we see the moon. So I think for me, we should have a third grouping that is driven by the people and for the people.
Thanks. Thanks. Is there any other comment, Lisa?
There don't seem to be any other questions there. Let me just check. Let's see. No, I think that's it for now.
Okay. So we are very close to the end anyway, and I wish to thank Dr. Claire Nelson for her really amazing presentation, and thank you, Lisa, for managing. For help me in managing this webinar. And Claire, I hope that there will be other opportunities to cooperate.
Thank you so much for having me. I'm delighted to be here. Tomorrow at the Jamaican Consulate, the group here, they got their event to be an official side event. They're having a media launch tomorrow. I signed on to their group. Again, it's not that I agree with everything they say, But I do think that even if we disagree with small points, I think everybody believes that we want to stay alive, right? So we have to find a way to work together.
That is good
So-
common ground, yes.
So I am going to be carrying Moon Village Association. I'm certainly going to announce myself as a Goodwill ambassador. I'm really thrilled to be a Goodwill ambassador because every time I think about the story I wrote in 2016, when I hadn't even heard about Moon Village Association, I just giggle and say, well, I did get ambassador title after all. So I'm looking forward to continuing to work with you. Thank you all. Take
Great.
care.
Thank you very much.
Bye.
Yeah, bye.
Yeah.
Thank you so much.